Thank you.
So thank you, everyone, for joining this session, the last session of the day. I really appreciate it. My name is Ray. I'm a developer advocate for the Google Cloud Platform. What that means is that I've been an engineer for the past 15 years or so, and now I like to bring some of the latest and greatest technology and experiences from Google Cloud to developers all over the world, and also, of course, the open source projects that we are doing that could be useful for everybody. So if you have any questions about this session, please contact me on Twitter @Satanism. And prior to Google, I used to work at Red Hat, and it's actually very, very nice to be able to have Galder joining for this presentation. So Galder?
Hello, my name is Galder. I'm a software engineer at Red Hat. I work on the Infinispan project, which is an in-memory data grid for Java developers. And previously, I used to work a lot in support, so that's why I'm bringing a lot of like JBoss application server and clustering support into this talk. And you can find about me, Galder said.
Yeah. And like I said, we used to work actually together on the Infinispan project before I joined Google as well. I used to be a small contributor to the project. So thanks again for joining.
Thank you.
All right. So what we're going to show today is this application that I have written a while back. I have to say this is probably the best looking application I can have ever written.
I hope you're not a UI developer.
I'm not. Yeah, I'm trying to be a backend developer myself. And I mean, but come on, look, it's got this nice horizontal line. That's a HR. I know that much, right? But what this application can do is that it's a microservices application that will do two things. It's two of the best example application put together. It's got a guestbook application where you can say a nice message, hopefully. And then you have the hello world service behind the scenes that will say hello to you, right? Very, very simple. And behind the scenes is doing using microservices architecture. We're not here to say whether it's something you should be doing or not, but if you chose microservices for some reason, right, we're here to show you to solve some of the problems. So here we have the front end. We have a UI service here, UI component. And we have two containers running behind here. We have the hello world service and a guestbook service.
That's a lot of services just for a hello world application, right? At the end of the day.
Yeah, I know. It's always all it does is to say hello to you. But it will help you to understand and navigate some of the common problems that you're going to run into with microservices. Okay? So rather than going through the details, why don't we just go take a look? So here I have my application running in a Kubernetes cluster. This is running on Google Cloud at the moment. It's using Kubernetes Engine, which is a managed service, right? But that doesn't matter. But what you need to know is that we provisioned very quickly like 5 different VMs here all through the platform. And we are running the Kubernetes applications here. So we have the Hello World UI. We got 2 instances because, we have that much load.
Because you need it for a Hello World?
Of course, yeah. And we have 2 instances of each for high availability, right? And here we have the guestbook service and so on and so forth. Just to show you very quickly like what that may look like. So here's the YAML files, right? With Kubernetes, what we always do is to write the deployment descriptor. So for example, I have the guestbook deployment here. And if I scroll down, I can see, for example, the number of instances I want to run, and also the configurations for Kubernetes, and also the image we want to run, okay? So I got this all deployed, and we also provisioned a load balancer. Again, these are out-of-the-box Kubernetes concepts. So we provisioned the internal load balancers here with the internal IP. And we also have this external load balancer, which automatically provision the external IP on the cloud platform in this case, right? It's all transparent, all automatic. So how many people here already use Kubernetes or have used Kubernetes? Yeah, okay, yeah, almost half the room. That's pretty cool. So with a simple configuration, we're able to just provision the load balancer, expose it on public internet. Everybody can see this app today, right now. And as you can see, it's a Spring application, so we're just going to go take a look. Oh, wait a second. Wait.
What?
Right. Wait, yeah, hold on a second. Huh. Did retry? Yeah. No.
What's that error? My level error page?
Yeah, 500.
Internal server error?
In a 404 in the same place?
Null?
No. Well, that's good. That means we're writing a Java application.
Or Go? Could it be Go?
No, well, the Go has nil pointers. I don't think they have null pointers. So no, this is definitely Java. I mean, look at that Spring icon on the top. Yeah.
So do you have a backup?
You mean like a video?
Yeah. Just
no.
to show the people, right?
No, I thought you were creating the video. No?
I didn't have time. I was walking my dog last night.
You were walking your dog last night?
Yeah.
I was at the speakers dinner last night. I thought you were doing.
Okay.
All right. So
this is embarrassing.
Yeah. Even though this is the first time we're doing a talk, I'm so sorry to.
And this is going to be the last one.
The last one.
I'm done.
Wait, Galder! No, don't go. Wait a second. So I know that all of the people in the room, like they probably went through a whole day of talk. They're just waiting, dying to see a presenter fail at their demos. And I guess this is your day. This is your session, right? So I guess we have to kind of figure this out. We can't just leave. I mean, we're only 6 minutes in. This is too early.
I don't know. I'm waiting for the party and the beers. Right?
The beer? Is there beer afterwards?
Yeah.
How many people want to go get beer? Oh my God, everyone! Well, yeah, but no, I think we should do some due diligence and try to figure this out. Let's see. So what happens when you do have a production issue? Somebody calls you up 2 a.m. in the evening. What do you do first?
Maybe look at staging.
Staging environment.
That's a good practice, right?
Yeah.
If you got a production environment,
okay.
Before you arrived at production, you would have gone through a staging, right? You would have created an environment where you test what you're going to deploy, right?
I hope so. Everyone here, everyone has a staging environment, right? You don't. Nobody is raising your hand. Nobody has staging environment. Everybody should have like some kind of environment that allows you to test. Of course, you never go to production without going through staging first. So hopefully everyone has an environment like that. And in my cluster, I'm using Kubernetes, so I can carve out my cluster of my machine into what we call namespaces, right? So we can do something like, hey, kubectl get namespaces. We can see that we have a default namespace and also have a staging namespace.
Okay.
And in the staging namespace, I have exactly the same application running there because in Kubernetes, the namespaces separates the applications. So you can use the same name, but in different namespaces. Okay, so we deploy exactly the same app. And we have my UI application there and everything. So let's see here. I have a different endpoint maybe I can try. And oh, there we go. We have the UI front end. So let's go give it a try. So this is not working. Production. And oh, OK. Well, that's interesting. My staging works. But of course staging works. You never go to production. Yeah, you never go to production without going through staging, right?
You go to staging, it works. Then you go to production, it doesn't work.
Or vice versa, somebody has an issue in production, but not in staging, right? And this is very obvious right now. This actually works.
So what's the difference between the two? What do we have running in staging?
The same application, of course.
Are you sure?
Yeah, so
look at it?
Yeah, so what we're going to do, like in Kubernetes, right, we're checking all these declaration files, right? I just showed you earlier, like I have this UI deployment, yeah, and I have this UI deployment, and if I scroll down a little bit, I can see that I'm running 2 instances. I can also see what image I'm running. So if I go down here, I have my image, right? This is my configuration, and I'm running a Hello World UI latest.
So that is a Docker image, right?
Yes. Yeah.
And you're running latest.
Of course, because it's all about CI/CD, right? Continuous delivery. We're deploying the latest all the time, no? Yeah,
but what latest is that? Is that latest like an hour ago, latest yesterday, latest a month ago?
I don't care. It's latest. But no? What are the issues?
I mean, you should be versioning your Docker images, right? You should be saying version 1, 2, 3. I mean, latest could be anything, right?
The latest could be anything.
I could be different in my machine and your machine, remember?
That's true, yeah. The latest on your machine, like if you built the app like 2 minutes ago, it could be the latest on mine, so there's no way for us to tell. Then I guess the question is, are we running the same image on production versus on staging, right?
Yeah.
And tagging your Docker containers is definitely a must. You definitely do not want to go with the latest. So we can actually check that very quickly. So if I go and get all the current instances of my application, here is the Hello World UI. Okay, and what we can do is we can do a describe on this thing. And when you describe any resource in Kubernetes, it's going to give you all the latest details. Yeah. And so, for example, in this case, we can scroll up. We can see the environmental variable that's being used to configure this application instance. But if I go up even a little bit more, there we go. I see the image ID. Okay.
So
and oh, here's the hello world, right? And that's the latest version.
So we need to remember the number.
Yes.
And then compare it with
staging.
Staging.
Yeah, that's easy. You got this covered, right?
Okay. What's the number?
Yeah.
0,
you have the whole thing?
3.
All right.
Okay.
Why don't I do this? You remember the first 4.
Yep.
I remember the last 4.
Okay.
Okay, 6, 2, 4. Okay. Everybody remembered? All right. Everybody pick a number and remember what they saw. All right. So now we can go to staging environment, right? So we can say get pods, and we can say, let me get the staging environment, and I can do the same thing. And I can do a describe on this pod as well. So I'm going to describe, and let me see if they are the same thing. So I'm pretty sure we deploy the same thing. So if I go up,
let's see.
Yeah, I can see the configuration, right? That's there. And if I go up even more, what was yours again? I don't remember. 624B, right? That sounds about right. That sounds right. Too many digits here.
So,
but yeah, so they are exactly the same application.
Well, no, we know it's the same Docker image.
Yes, yeah.
But does it have the same thing behind?
What do you mean?
What does it have?
The same application behind it?
What does it have? What is that behind that Docker image? What do we have? What kind of application? What version of the application?
What is actually inside?
Yeah.
Well, that's easy for me to tell. Hey, somebody said cool guy. Nice. Hey. Somebody in the room is saying good stuff. Just make sure you say good things. So I can show you the Docker thing that I created, right? So if I go to my example Java here, and if I go to my UI application, right? And I got my Docker file, and this is how I'm building my app. And oh, look, there it is. Yeah, that's my app.
Snapshot. Ray, what the heck, dude? I mean, you used to be a crop developer before when you worked for us, and then you went to developer. You're even worse now, depending on when the snapshots.
Wait.
No wonder your application does not work or your demos don't work.
So I cannot do the front end, and you're saying my back end is not doing well either? No. Well, that's quite horrible, yeah.
What's the problem with depending on the snapshots? I mean, it's you never know what you're gonna get, right? It could be any jar files.
Yeah, that's true. But you are going to run into issues like this. Hopefully not in your company. But when you go to a new company, you might run into an issue like this, right? You just don't know what versions are running. And you need tools to provide you some insight. So potentially, some of the tools is you have a really good CI/CD pipeline. You could be using some kind of registry that stores the metadata of how the build came about. So the things that we have here is actually we actually put this image into Artifactory. So what that means is we can describe the pod, right? And we should be able to get the hash. Where's the hash? There's the hash. And we have no idea what this hash stands for. And if you have a system that can tell you and that keeps record, like in this case, I'm going to use Baruch's repository here. I'm going to log in. Uh-oh, yeah, so nobody reads my password, yeah? Oh, there we go. Anyone see it? No? Good. So we can actually do a search, and maybe we can find the checksum here. So we can go to checksum, and maybe we can see what image is this. Oh, there we go. Yeah, this is version 50. Latest is version 50.
Okay, version 50.
Yeah.
But that still doesn't tell me anything.
No? What else do you want to know? Look, here we got 27, 31. What happened to 28? I have no idea. But we got 50. That's the latest one.
But 50 is deployed by Mark Yi.
Yeah, Mark G.
I'm not Mark Yi. You're not Mark Yi.
I'm not Mark G either. Is that somebody you know?
Who's Mark Yi?
I have no idea.
I don't know.
Yeah, well, that's too bad. But Mark created this image. I know I've been using it for a while.
Do we trust Mark? Do we know?
I trust Mark right now. That's my only hope.
Okay.
Yeah.
Thanks, guys.
I don't know. I mean, I have no other things I can deploy. This is the latest one.
Okay.
It must be the good one. So let's take a look even more. Like we can actually potentially go in if you have the metadata. You could potentially say what build this came about. So you can see the build pipeline. Now, in this case, because we built it from a CI/CD server, I believe it was Mark's CI/CD server, but Mark left the company, so the CI/CD server is not there anymore.
How typical. How often does that happen with Jenkins or Hudson? Like, it becomes unavailable.
Yeah, or like you lost the configuration to deploy. But that's okay because the metadata is still here. So you could actually go in and see the modules and whatever is associated with this file, right? But that's one way for you to get, the key here is you need a good way to keep track of your metadata during your artifacts. But I think at this point, Galder, I feel like we have the right application. I mean, it is the only version. It is the latest version. And it's the same versions on both environments.
So
you know,
what do we do?
Well, we have the error message here. Yeah.
Maybe we can check logs. Maybe
the log. That sounds like.
Show me the logs.
That sounds like a logical step. Everybody wants to see a stack trace.
Yeah.
So in Kubernetes, that's also very easily done. So for example, when you have the ID to that instance, which is we call the pod, right? We can always do something like kubectl logs -f, and I can just give it the instance name, and then I can see the log. I can tell it. But now this probably happens to everyone. I got 2 instances here, right? Of course, I only have 2 instances. What are the odds for me to find this exception in my log?
50-50?
You have to think that long? There are only 2.
Come on, I don't know. I need to think. I'm
50,
working.
50. All right, got it. No. But in Kubernetes environment or in any microservice environment, right? You don't just have 2 instances. You may have 10 instances, right? If I scale this up to 10 instances and I go to get pods, you know, wow, now I have so many. Then what are the odds of finding the exception in the logs?
50-50?
How?
Well, you either find it or you don't find it, right?
What?
It's the same, right?
Yeah, I guess, yeah. You either find it or you don't. I guess they're independent probability. But I don't know. But there's something wrong. There's something off with that math.
Okay.
But let's just say we are able to find the log. Yeah, it sounds good to you. Oh, there we go. I'm very lucky today. There we go. I have the log, and I can see all the exceptions. I'm telling it, and that's not too bad. But I have 10.
Well, but that's okay.
So I guess if you don't find it, right, you have to go find another one, right? That's
okay. Are you? Is this what you're going to do in production? I mean, when I was in support, I normally had to kind of do these in going to production systems, going to fetch the little logs.
Okay.
I had to grab them. I had to find them. Am I going to have to do the same thing again? Am I back to 10 years ago?
10 years ago? Yeah, well, how many systems, how big was your cluster? Like?
Well, I used to have 20, 30 node clusters with logs from multiple days, and then I had to go into them, had to kind of go individually, take them, download them.
Okay.
Spend many hours going through logs.
And you're an expert in grep, yeah?
Yeah, am I going to have to do that again?
No, I hope not. How many people here use grep to see their logs? Do you want to see a show of hand? Yeah, there are some people out there that's doing it. Hopefully no one has to do this. But like in Kubernetes, there's a really easy way for you to tell all of the logs, not just one. There are some tools, right? Like one of them is called CubeTail. So you can use CubeTail to say, just give it the name of the application, and you can just tell the log. And of course,
if it works,
there's nothing there. And if I refresh, if it works, Wait, what? What's going on here?
Maybe you need to wait a little bit.
Yeah, maybe I need to wait a little bit. Oh, there we go. Yeah. Oh, there we go. Oh my goodness. So now I'm seeing the logs. It's the Wi-Fi that's killing me.
So what you
see now you see all the logs.
So what you got now is logs with colors.
Yes, but from all of the instances, right? I can use another utility called Stern. That's another really handy utility. I can use Stern, and I can tell the logs this way too.
Okay.
And I can just see all the logs, right? That would help you to not having to SSH to all the machines to see what's going on.
Yeah, but that's gonna work as long as you've got 1 request per minute.
Like that.
I mean, in any production system, you're going to have a lot of customers, a lot of users. They're going to be hitting your application. Or you're going to see, if you use a tail approach, you're just going to get like an endless scroll of log messages.
Endless scroll of logs, yeah. And it's not very useful when you're in production environment in this case, right? You're absolutely right. And that is why in Kubernetes, there are a lot of integrations with some centralized loggers. So for example, you can set up a elk stack, like Elasticsearch and Logstash and Kibana. And in different Kubernetes clusters, they have different setup, like OpenShift, Kubernetes cluster, what do they use?
ALK as well, Elasticsearch, Kibana, and
was it Fluentd? Yeah, But so you need to look into integrating with some kind of centralized logging. With a centralized logger, all of the logs that you output to stdout or stdarrow will be captured not just by Kubernetes, so you can inspect it with kubectl logs, but you can also inspect it in the centralized logger as well. Most of them are able to pick it up directly from your output stream.
So then I can run grep on those local messages.
Then you don't want to run grep. Then you go into the console. Then you can do a search, right? And these logs, it's very important to remember. Do not write the logs to the file system because the file system in a container might actually get filled up. And if you don't actually rotate the logs, or if you don't restart the container, your file system will get blown up. So it's very, very important that you output the log to the console and remove any file system logs. But if you do it this way, then you can use a centralized logger. So for example, here, in the Kubernetes cluster I provisioned in Google Cloud, right? Out of the box, there's a centralized logger. Basically, it's a logging tool, right? You can use anything like on-prem, and in the cloud, they're a little bit different. But like here, I can actually navigate into my cluster. I can see the namespaces I need to look at, right? So rather than greping the log, you can just run the log here, okay? So let me close out.
So I don't need to download them. Once my logs are there, I don't need to download them. I can look for them.
You can do a search. You can even narrow this down to the application that you want, for example. In most of the centralized logging tool, you can do this. And this is far better than what you have to do before, right?
Yeah. So far, so good.
So far, so good.
I prefer it.
Yeah. But it's not enough, right? I mean, some cases, even though you have access to the log, you might want to analyze it a little bit.
Yeah, I mean, just being what you're doing here is what you're showing me so far is what I could do with grep, right? I could take a log, I could just grep through a particular thing, and then I got all the matches. What's different here? Well,
so one of the things that I like to do when I was troubleshooting a production system for a hotel company, so this is where you book your hotels. I remember they had like 10 servers or something, some big servers. And whenever something goes wrong, in 2 a.m. in the morning, the first thing I want to determine is, okay, is it working staging? Is it just production issue, right? We look at the logs, we try to look at the logs, we see the error, and then I wonder, is this exception happening only on one machine, or is it happening on all of the machines? Because the way I deal with it could be different. If it's on all of the machines, I know I screw up something huge, and I gotta fix it quickly. If it's on just one machine, maybe it's an environmental issue or something else. Then what do you do if it's just happening in one instance?
You kill it.
What?
Restart it.
You just restart it?
Yeah.
No. That's bad. If you find the instance that's bad because it's 2 a.m., you just want to restart it and go back to sleep.
Well, if it's a Java application, that's quite common, right? You've got garbage collection issues. Suddenly, your JVM is not accessible. What do you do?
But if you don't figure out the core problem, you're going to see the same problem again like a week later.
So you set a cron job, and then you do it every...
What? You just want to go. How many people here have cron jobs that kills their JVMs? I heard this to be true. Oh my God, there's some people who are raising their hands here. All right. Yeah. But that's the problem. If you kill something, you won't be able to debug it anymore. But so let's ask the question first. Let's figure out
Let's interrogate it.
Let's interrogate it. Not yet. Yes. Well, we got to find who to interrogate first, right? So for example, we need to be able to extract more information from the log. So a lot of people, they dump the log into Hadoop or something, and they run a script or MapReduce to try to figure out these answers. It's no different here, except you can get the answer potentially much faster. So from the logging console, you might be able to dump the log to somewhere else, and then you can stream it. You can do real-time analysis on your log messages. Or my favorite is actually this one. Potentially, if you get your log into a system like BigQuery, then you can actually query the logs with SQL.
Whoa. Okay.
Yeah.
So instead of grep, I use SQL.
Yes. Yes, okay. but you're a Java developer. You know how to write SQL, right? Or just use Hibernate. I don't know.
I use Hibernate.
You use Hibernate.
Hibernate. That's the way to go.
But then you have HQL. So everybody knows how to write SQL. I hope everyone here knows how to write SQL, right? But if you don't, it's really easy to learn. So here we can actually go to the BigQuery console, for example. If you have the log in a system like this, then what you can do is to ask interesting questions. So in this case, we're not using grep.
Interrogate.
Interrogate. Asking questions nicely. Yeah, we can ask a nice question, simple question of like, hey, what are all the exceptions on the Hello World UI? I want to count the number of times it happened. I want to know which instance it happened in. And then I want to group it by the name so I can sum it up. And want to order by to see if there's just one instance that's having the issue or multiple instances that has the issue. So I can run this query. Oh, and look, there's definitely one instance that has more issues than the other.
Kill it.
No.
Come on.
No.
Kill it. Come on.
We're not killing anything here today. No. I try not to, at the very least.
Okay, if we cannot kill it, what about we put it in isolation?
In isolation.
Like to interrogate it, right? So you get,
Stop. Just ask questions. Ask questions, yes. But what would you want to isolate? How do you want to isolate?
Well, I think normally what I would have done when we had a problematic instance, we would probably separate it from the traffic, right? So you want to keep it running, but we want to kind of make it stop serving requests.
Okay.
And then that way we can do fun things with it.
Yeah.
And then while the rest of the system works.
Okay.
How's that?
Yeah, so that sounds like it's something that we can actually do. So in Kubernetes, the way that you set up the load balancer is by specifying these special labels that you can use to determine what instances of the application can route the traffic to. So in this case, I have my load balancer set up that routes the traffic to Hello World UI, but also with a special flag that I created myself, code serving is equal to true. So what that means is all of these running instances, if I say get pod, if I see serving flag, the serving label, I can see that all of these instances has this, the serving flag to be set to true.
Okay.
So I can isolate one of these instances if I just set it to false, right? So I can do something like override the flag, like that, and let me just label the pod so I know which has the issue.
Okay.
Then I can write the flag to say serving is false. And what that's going to do is to take this instance off of the load balancer, and now you can try different things with it.
One second.
Yeah.
But now there's a new instance here, right?
Yeah. So what happened is that I specified, remember I scaled my instances to 10, and I took one of them out of service? So Kubernetes is smart enough to be able to create another instance for you to take over. So in this case, I removed one instance, it added one instance back, and that's just being started 4 seconds ago.
So that means that if you say replicas equals 10, and then one of them stops serving, Kubernetes is always going to try to create enough instances that are not up, but serving.
Yeah.
Right.
Yeah.
Okay.
Yeah. Pretty much. If it crashes, it will restart it for you automatically, like when your GC has issues. Like rather than writing a cron job, we'll just do it for you. But don't depend on that, right? So now we have this.
Yeah, but if it restarts it, then you cannot interrogate it anymore.
Exactly. So now we have the instance isolated, right? Now we can do interesting things. Like what questions would you want to ask in this case? Like what is going on with this application?
Well, we can maybe try to access that application individually.
Okay.
So maybe we can, I think in Kubernetes, you can do this port forwarding thing, right? Where you can forward one of the ports. Yeah.
So we can actually, if you want to try to see if this particular instance actually has the issue, rather than going through the load balancer, which you have no idea where it's going to end up, if you want to pinpoint a single instance, you can set up a pull forward. And what this will do is to set up a local port and a TLS tunnel into the system, into your cluster, if you have access to do that. And it's going to listen on port 8081, right? In this case, because I said 8081. And I can actually just go ahead and try it out. So I'm going to say 8081. And, oh my goodness. Wow, this actually works.
Whoa.
This actually, what? Drop table? Who? Who is that person? Nice try. So this instance is fine.
Yeah, but this is quite confusing. So we've got the main entry point. It's not working.
Yes.
But then we hit the particular instance, it works.
Yeah. So I guess this instance is okay.
Well, but can we do something else? I mean, how is this all interconnected? I mean, why is it different? I get the feeling whenever we write in this kind of microservice architectures, then it's quite complicated to know how the different pods interconnect, the load balancers, because if I'm hitting that node, it works, but if I go through the load balancer, it doesn't work.
Yeah, because microservices architecture can be complex. You may have multiple services you're serving. One could be calling another. All of a sudden, you have 10, 100 services. How would you know who's calling what? And in this case, right, we can actually go and I got this great console. By the way, this is open source. You can actually do this yourself. And you can clearly see, right, the Hello World UI is talking to the guestbook service. You can also clearly see the Hello World UI is talking to Redis and so on and so forth, right? I mean, this will help you to debug it, no?
But is that UI that you're showing me, is this being updated real time?
Almost. So for example, if I scale in the number of deployments, right, like to 5, I will actually show 5 instances here.
Okay.
But
what if I add a new service?
If you add a new service,
you reroute your requests.
So these lines will not show up properly, and that is because I hard-coded them.
You hard-coded them?
Yes. So for example, in my deployment, I have little annotation here that this specific visualizer talks to, and I hard-coded which ones that they're talking to, of course, right?
That's like doing diagrams by hand. This reminds me like when you have situations where you've got this documentation, right? Where people have written these nice diagrams at the start of the production system, like this.
Yeah.
And then you suddenly go into production, you say you have to debug a problem, but someone comes a few hours later and says you, hey, you know, what you're looking in there, that's not how it works.
Yeah, so the documentation could be outdated.
Yeah, it could be outdated, and you could spend hours like going through information that doesn't match or represent what is happening in real life.
That's right, yeah. And in this case, if I added a new service, it wouldn't show up because I hard-coded it. It's a piece of documentation.
Or if you made a mistake, for example,
if I made a mistake, then that's not good. So this is why in a microservices deployment, you need full observability and insight into what it is that your services are doing. So I'll show you one of the tools that's pretty cool to get a real-time view of what's happening. There's a little utility you can install on the cluster. It's called Weave. Let me see here. Where is it? Weave. Yeah, it's running on 4040. So let me just go find Weave here. No.
On Google,
no, not there. Yeah, but you can find it. Every cool thing is Weave.io. Is that right? No? Yeah, it's very slow. No, not that one. Weave.com. Let me see here. Why is the Wi-Fi so slow here? No, definitely not that one. No, it's WeaveWorks. WeaveWorks, right?
WeaveWorks.
So if you install something like WeaveScope, what you can get is potentially a real-time view into the networking of your cluster. So if this internet is any faster, this console will load, and it should actually show me all the existing connections that I have from my service to other services. And these network connections are represented in real time. And so when there's a new connection, then it's going to show it.
Eventually,
if I have my, what the? All right, let me that definitely crashed. Let me try this again. There we go. There we go. So you see here, if I zoom in a little bit, I can see very clearly my Hello World UI is talking to Redis. And it's talking to Hello World service. And if I do a refresh, it still doesn't work.
But
you should see new lines coming up. There you go. Did you see that? The new line just created, yeah.
Yeah, but that's not going to cut it.
Why not?
Because all this is showing you that Hello World UI talks to Hello World service.
Yes, yeah. Is it not what we want to know?
No.
What else do you want?
What about we use something like distributed tracing here?
Okay, what is that, and what is that?
The idea behind distributed tracing is that we can represent individual requests happening within a system, within a microservice architecture, and we can see requests, which requests are going through which services, how many times a particular service calls another one, and then we can see things like information like login or like information about the particular service. And for example, we can see how many times it calls, right? For example, if you have a slow service, we can see maybe we're calling it too many times.
And how does that work, like for distributed tracing to work?
Normally, there are tools like Zipkin, or there are open tracing as well that allow you to add distributed tracing to production systems in ways in which you don't impact performance, which is very important.
So like what they do is they will attach like a request ID or a trace ID if that one doesn't exist yet. And then when you make another call to another microservice, you will hopefully automatically attach those IDs to the headers of the outgoing call. And when you have all of these different requests that can be correlated by a single request ID, then you can go back and you can build an entire code stack of the multiple services, right?
There's some cool user interfaces to do that as well.
Yeah.
Do we have anything like that?
Yeah, so you can use Zipkin. Zipkin has a nice console for you to do this type of visualization of the code stack. If you don't want to host your own Zipkin, right, the concept is very similar. You can use other components too. Same thing here, like on the cloud, we have some hosted service too that you can use, so you don't have to kind of worry about what it is, how much trace you need to collect. So for example, with distributed tracing, I can click into any one of them. Oh, wow, this is not a very efficient application, is it?
Whoa.
It's
you see?
Yeah. So like here you have the entry point, and then you can see exactly what's going on throughout all of the services code. So the home page made the code to the guestbook messages, and that code other things. And you can see that this is sequential, so it's not very efficient. But I'm more interested in the one that had issues. So I'm going to find the one that has 400 error.
404, right?
Or 500 error. Oh. Yeah, 500 error. So there we go. So these are the services code that has 500 error. So there we go. So here's the thing that came in. I can see that there's the 500 error.
Okay.
And I can see that it made a call to hello, right? And I can see that the hello service returned very quickly. And there's, in fact, the 404 error that's caused by one of the services.
Okay.
Okay.
So
that's not bad. Okay. But yeah.
So now we need to look at the logs. Now can we look at the logs to see what happened?
Yeah. So if you tie everything up properly, when you click on the view log in the system, in the right system, it will actually give you a correlation to the actual trace ID in the log system, and it should actually find relevant logs in the system too. And as you can see, we have no logs. No.
Okay.
No, but let's try this. I'm gonna see if we really don't have any logs, so I can go back to the system. Now we know we got this. No more greping, right? I can actually go and see if we have an issue here with hello or service, and I can go see this and load neural logs. Nothing. Wow. I have no log whatsoever.
Okay.
Yeah. So that's not good. That's
so we need more logs, right?
Yeah. So like during the production troubleshooting, usually we check the environment, we check if we have the right versions, we go through the stack traces, we try to figure out that visibility into the cluster, and then finally, when we have no other options, we need to see more logs. We need to see what's going on.
Yeah, but that's going to be quite a pain to deal with, no?
Why? Just add another log, no?
Yeah, but now you're having to, you've got your application, you need to figure out what's the source code for it.
Okay.
You have to go check it out.
Okay.
Add your login message.
Yes.
Compile it.
Yes, of course, yeah.
Deploy it. How long is it going to take to deploy it?
Well, I don't know about you, but as you can see, I deploy the latest all the time, so it takes like 2 minutes.
Okay, but what if you have like a very little window? What are you going to do?
No, that's true. Yeah. So in many of the customers I talk to, the turnaround times may be like an hour, on the orders of hours, right, to deploy a new thing into the system. And if you don't have the log that you're looking for, what do? You go through the same process again.
Man, that's gonna take a while.
Yeah, it could be, right? So this is where you do need a right CI/CD pipeline set up. Do not deploy the latest, but you want to know what versions are being deployed. But if you're out of options, and like in my hotel experience, the traffic comes in at 8 a.m. in the morning. So if I have a production issue at 2 a.m., I need to deploy everything and fix those issues by 8, because otherwise we're looking at the entire day of downtime, right? Well, because when all the traffic's coming in, there's no way for us to catch up and serve everything.
Or you're out of job.
Yeah, exactly. So when you're out of options, this is the only thing that is attached, only that works on the cloud environment, is called debugging. So what we can do is, if you share the source code, either you upload the version that's right, or if you're on GitHub, we can synchronize the source code automatically. You can come to this console, and you can find the right version of the application. This is done automatically. And if you want to have more log message, you just add more log message. So for example, here I'm going to add a new log. For example, here I'm going to say, how do we debug with the log messages in production environment? You say, 1, I'm here. Is that how we do this all the time, right? I say, 1, I'm here, and maybe I want to know what the name is, so I add another 1. I say, 2, I'm here,
Whoa.
What? And name is name, just like that. And then finally I say 3, I'm here, right? We do this all the time in our logs. And that's it.
Yeah, but how does this work? Are you actually modifying the source code?
No. So what happens behind the scenes is that we are running a agent that's attached to your JVM. So you can configure this yourself. But once you configure the agent, let me see if I can find that particular example. Let me see here. Once you're running the agent, you just add it to your JVM startup command line. What we can do is to just make a secure connection to our debugging tool. And this is just intercepting the calls. And then we generate additional log messages for you.
OK.
Yeah.
Oh,
Yeah. So for example, if I want to show you how this is done, if I see the Docker file, and here's the agent that we're adding, and that's it, right? And we determine the name of the agent, and it kind of shows up. Now, even though we're running 10 instances of this service, when you add this log message, it's automatically propagated to all of the logs, all of the application instances with a matching version. This is quite cool, right?
So this is going to, in Kubernetes, the way it works is it's going to install it in one application, then another one, or is it going to deploy new pods, or how does it?
So there's no restart. It just gets applied, and you just get to see all the log messages. So if I do a reload, and if I go to my log console, and if I look into here, there we go, log point, I'm here. There's no restart, there's no redeployment. We don't modify your code, and it just works. And if we go down here more, I can see more of it, right? So it's pretty straightforward. Yeah, so that's pretty cool. But there we go. There's another log message here, and I'm here. Why are people just hitting my service right now? Is it just getting very, very popular, or all of a sudden, like everyone's trying to do this, right? But this will eventually catch up, right? But what's more important though is that if you still can't determine what the issues are from the logs, wouldn't it be nice to be able to debug your application in production?
Ray, we cannot debug applications.
Why not? Just attach a debugger.
No, you can't.
Why? What's the problem there?
Well, then if you attach a debugger, then you're going to have to kind of press a button, not to.
Why?
To
because
lines.
It stops the world?
Yeah.
And I have to go through the steps through all the code?
Yeah.
Well, that's great. I get to keep my job whenever something's slow. No?
I'm not sure your bosses are going to be very happy if you do that.
No? But wouldn't it be nice, though? Wouldn't it be nice to just go into your production environment and see the code stack, see everything that's going on? And we can actually do that with the same agent that you put onto your application, for example. Rather than adding a log point, you can just attach a snapshot. So what this will do is to say, OK, I wonder what's happening here. I wonder what is happening in this service right here. So I'm going to add a snapshot here. Okay. So now if I go and make this call, refresh, and if I come back to my console right here, did you see that? Just it gets attached to every running instance, and now we can actually see what's going on. The name is empty.
Name is empty?
Yeah, the name is empty.
Sure.
Somebody forgot to put the name in the UI.
So then that's a user error.
That is definitely a user error.
If the name is empty, come on, if you're doing a hello world.
Yeah, exactly. Who wouldn't put their name in there?
User error.
Yeah, but I guess I was the user, wasn't I? Yeah.
Yes, you are.
It was me. It was my error.
Application.
It was my error, right? So, but to show you why this is happening, and this is, I stumbled upon it myself in another presentation before, and somebody said, oh, shoot, your application is not working. That is because if you look at the code, and again, this is a bad, stupid issue, right? If I look at the code, here is where the name is being grabbed, right? And the name is a session attribute. Okay, so if I make the first call with the name, this kind of gets to the hello world service. And when the hello world service doesn't get any names in the parameter, then it returns 404. So I guess that was the problem, right? Yeah. So long story short, right? When you have a complicated microservice deployment, you really, really need some toolings to help you navigate and solve these issues, because sometimes a simple issue like this could take a long time to resolve, right? So for example, we went through quite a few different tools here. Just remember, like there are tools within Kubernetes itself that can help you isolate your instances and pull forward to a specific instance to debug. There are ways for you to remove an instance from the running serving path. And then there are other tools like Stern and CubeTail that can help you to see what's going on right now, or Weave and Weave Scope. And of course, you need tracing and right. So microservices architecture is not just about running and deploying your application. It's about getting insight into what is actually happening. Okay. And there are a lot of things that we can do, of course, and we have tooling from Google Cloud, and different on-prem installation has the right tooling too. And you really just have to figure out what is right for you in order to allow yourself to not to get stuck in a production environment, production issue for so long. Okay, and yeah, I think that's all we have so far. And if you have any questions, feel free to reach out online. And if you want to see the source code and how everything is running, you can go to my GitHub on saturnism/springboot-docker. Okay. So with all that said, any questions in the audience? Are there any questions that you may have? No? Yeah, well, that's good. That's good. Some people always ask about the debugger because they will be saying, well, hold on a second. If you actually said, you want to print the name here, you can actually add an expression. And this expression is going to code the getter if you're on an object. Then the question is, what happens if this expression modifies the state of the code, right? Wouldn't that make everything so much worse? And it would definitely make everything so much worse, right? If you're arbitrarily adding code into your production system without going through the proper Git repository, then you don't know what's happening. But in this case, we actually detect whether the getters actually modify the state of your application. And if it does, we will just fail this call and just never allow it to be called at all. Okay?
I have a question.
Yeah.
What if you make a compilation error there? What if you add in your log message, you
make a code to a non-existing variable?
Because log point here doesn't have like a semicolon at the end.
You don't need it. You don't need it. Right?
Is this Ruby?
No.
Is this Groovy?
No, but the templating engine allows you to have this kind of template with the variables, right? But however, if you refer to a non-existing variable, then we will fail the code. This will not kill your production system. Yeah.
Oof. Yeah. Well, okay. That's at least something to be thankful.
Yeah.
I don't want to be adding one. This otherwise feels like PHP, right?
Well, not quite. This is much better, I hope.
Okay.
Yeah. So, with all that said, if there are no questions, there's one. Yeah, go ahead.
Yeah, I can speak louder. But it's no problem. I have just a question about the breaking point.
Yeah.
The breaking point is not really breaking the application, but is spread to every instances.
Correct.
of our cloud.
Correct.
And what's happening behind the scenes?
Right. So what's happening behind the scenes is that this is not a breaking point. We call it a snapshot because we don't stop your code. We don't stop the world. You don't have to step through. But as the code is going through this, and when the agent intercepts this, what it's going to do is to capture the code stack, right? And then forward this back to the central console. So it's all being done transparently. And then it gets forwarded here. Then you can see what's happening for that particular line of code for that particular request. So you can actually dig into all of these things one by one, and you can see all the details. Now, however, if you are trying to isolate a problem, if you have like 1,000 QPS flowing through your system, the first one is going to hit this snapshot point, right? The first one, everybody's going to get their logs. You may just end up with more and more logs. So that's why we actually have a way for you to add conditionals. So you can actually isolate this if you know a request ID or something in the request in the scope that you can access, like in the code. You can actually write an expression to say, do this only if the request ID is equal to something, or only if certain conditions are true. Then you can really debug this in production environment, trying to extract data from it. before you actually try to reproduce it in your developer system, right?
This feels very similar to what you get like in other IDEs, right?
Yes.
Like Eclipse or IntelliJ.
Yeah, yeah. In fact, you can actually run the plugin in IntelliJ. So we have a plugin in IntelliJ. If you have the right permission, you can attach the same debugger, and you can do this in real time against a system that you have access to, right? So, like a lot of the times is that you cannot reproduce on your staging environment. You don't even know why this is happening. That you really need to go to production and just take a look. Yeah.
We have one more question.
Okay, go ahead.
Hello. Do you support any other languages, JVM or even non-JVM languages with this snapshot feature?
Yeah, so there are some support. So I don't recall what the latest set is. So I'm going to look it up. I don't like that first one. What was that? Oh, never mind. Yeah, I don't know what that was. All right, so here's the debugger. There we go. So we have Java and Python pretty much in production, partially because we run the same debugger, practically the same debugger in production Google code. So some people ask like, how much overhead are we adding? It's nominal where we actually run this in production today ourselves. But here are the other ones that we can support, Go, Node, and Ruby, and PHP. Oh, so you don't have to write console.log anymore in JavaScript, potentially. Yeah. Right? OK. Any other questions? No? Oh, yes? One more? Last one? OK.
So my question would be, how much of this is depending on the Google Cloud, and how much is only Kubernetes specific, and we could just run it on any Kubernetes cluster?
For debugging specifically, or for all the things I showed?
For all these fancy things you showed us, but for debugging in particular, yeah.
Yeah. So on Google Cloud, everything is based on the API. So you can actually run a debugger agent in your application outside of Google Cloud. That is not a problem at all. The only thing is they do have to be able to connect to our server in order for you to use this console or to be able to propagate the information. So it's just you need a networking port open to be able to connect to us, and then you are OK. Similarly, like with like Trace and everything else, you can always run an open source alternative, right? Like Elk Stack or Zipkin, right, and a few other things.
Yeah, if you run in OpenShift, for example, there is integrations with Open Tracing, and there are integrations with Elasticsearch as well for log aggregation as well. So a lot of the parallel features are also available for OpenShift users, which is very interesting for on-premise, like not on Google.
Yeah, but because it is API-driven, so you can actually send traces to here too if you want to. But it's not guaranteed. It's not like necessary. You can always host your own if you need to. But if you need a hosted, like completely hosted solution, you can always use these solutions separately. That's not a problem at all. Okay. Cool. Well, I guess that's it, right? Anything else, Andre? No? All right. Well, thank you everyone for staying for the last session. I really appreciate it.
Thank you.
Thank you.
Thank you, Ray and Galder. And so, as you know, there is a welcoming party downstairs. There's some beer, there's some apero. Don't forget to vote when you leave in the room, please. Ray and Galder will appreciate your feedback. And thanks for joining Box de Zurich again.